Good afternoon, everyone. I would like to thank each and every one of you for being here with us today. I'm Nisarg Shah. I'm an associate professor in the Department of Computer Science here at the University of Toronto, and I'm also a research lead at the Schwartz Reisman Institute for Technology and Society. So before we begin today's session, let me take a moment to acknowledge the land on which the University of Toronto operates. For thousands of years, Toronto has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. While some of us may be joining from different places today, we invite you to reflect on the history and the relations of the land that you are on. A few logistics before we begin. This session is being recorded. Our speaker will speak for about 50 minutes, and this will be followed by a Q&A period. And during this Q&A period, we encourage all the participants to use the raised hand function in the Zoom meeting controls to ask a question. And when it's your turn, we'll invite you to unmute, and then at that point, you can turn your camera on and then ask the question to the speaker yourself. But if you're in a space where you cannot ask a question directly, then feel free to write your question on chat, and then I'll be happy to pass that on to the speaker on your behalf. So without further ado, let me introduce today's speaker, Ann Copestake. Ann is a professor of computational linguistics in the Department of Computer Science and Technology at the University of Cambridge. Her research involves developing computer models of human languages, or more precisely, models of some aspects of human languages. In conjunction with DELPH-IN, an informal international consortium, Ann has developed software that has been used to develop formal computational accounts of the syntax and compositional semantics of many different languages. Her current research focuses mainly on the development of models of semantics that are compatible with broad coverage computational processing, parsing, and generation in particular. And Ann is also interested in the formal aspects of combining distributional semantics with model-theoretic accounts and in utilizing DELPH-IN technology to establish the performance of deep learning systems according to linguistic criteria. She has worked on a variety of application areas, including scientific text processing, information extraction, augmentative and alternative communication, machine translation, natural language interfaces, lexical acquisition, and tools for lexicographers. So without further ado, Ann, the floor is all yours.
Thanks very much. Let me share my screen. This might take a moment or two while I mess around with technology. Oops. Okay. Righto. Is that okay? Good. So thank you so much for the invitation to give this talk. One thing I should explain is that although a very kind introduction described my research areas, I've actually spent more or less the last 6 years being a head of department in head of a computer science department in Cambridge, head of the computer science department in Cambridge. And those 6 years were complicated, and I'm now on sabbatical, so I'm now coming back to doing research, but my research, definitely went rather quiet. And in a sense, this is a very strange time, because when I started being head of department, computational linguistics was this fairly niche, small field. And then suddenly everything has exploded. We are now in the era of LLMs. Everybody's heard of ChatGPT. My field has changed out of all recognition. And so what's happening today is that I've got a mixture of interests as I come back into doing research. And I'm hoping that my attempt to bring that mix together is at least somewhat interesting. Although some of the things that I'm going to talk about are the research that I have been doing, mostly with my PhD students over the last few years. But other things are sort of perhaps more recent interests. So this talk is actually very much related to the work of Karen Spark-Jones. And I'm taking this idea of the information layer from Karen's work. Now, So therefore, there's a sort of historical strand in this. And of course, because I've been in NLP for a very long time, and by the way, I'm going to keep saying NLP or computational linguistics, and tend to use NLP when we're talking about the more applied things. Computational linguistics is actually more my enthusiasm in terms of thinking about the models of language, but I'll use them more or less interchangeably. I've been working in that area since the 1980s. And so, I have some historical background too, historical baggage, in fact, you might call it, but anyway. So there's this historical area of relevance. There's also this sort of interest in where the field is going, and in fact, in the relationship between of NLP to computer science in general. And that I hope will become apparent as I talk. And in a sense, there's a sort of general background here, which is I'm hoping that I can use my expertise and background over the next couple of years to help people understand where we're going with the field, what's happening with the field. Okay, so here's the rough outline. I'll talk a bit about Karen and some background and some assumptions that I'm making, which are a little bit strong in some cases, but it's sort of a starting point for a discussion rather than saying that I'm necessarily right. And then I'll talk a little bit about LLMs from a sort of user perspective. I'll talk about systems and the information layer, and then I'll talk about some prospects at the end. One thing you should watch for is there are going to be some red dots that appear in my slides. These are places where I know that if I start talking about this could end up taking a very long time. It's a sort of rabbit hole indication. So, please feel free to ask me questions about the rabbit holes after the talk, but be aware that there might be some long answers there. Okay, sorry, I'm just going to fiddle with Zoom because this is hiding some aspects of my slides in a way I don't really like. Anyway, right. So, Karen, I will admit to a feeling of guilt here. When Karen died in 2007, rather suddenly, I was supposed to bring out her collected works within a reasonable time frame. One of my main objectives, now I'm on sabbatical, is to actually bring out Karen's collected works. And so this sort of thinking about Karen's work in the information layer, which is stuff that she published just before she died, and I really didn't have much chance to talk to her about it, even though we were in the same group. Thinking about that is actually my attempt to do some research at the same time as think about this sort of current context for Karen's work and finally bring this collection out. So what we've got here is Karen was a founder in both fields of natural language processing and information retrieval. And Karen actually also always spoke about natural language and information processing, NLIP. And she was the founder of the research group that I'm also part of in the computer laboratory in Cambridge. And she always used that abbreviation. So when I say NLIP, I'm going to be trying to combine both NLP and information retrieval. But her earliest work her earliest computational work was actually on what we call distributional semantics, which is the ancestor of language models and large language models. And so her 64 thesis plus later CLRU reports, Cambridge Language Research Unit, I'll mention that a bit more in a second. Those were absolutely foundational in this area. And that's something where I won't really talk about that today, but that connection has been unfortunately somewhat lost. She was also known for doing classic work in information retrieval. The idea of inverse document frequency is due to her. Again, I won't go through that, but this contributed to the technology used in early search engines such as AltaVista. She had this emphasis on evaluation and shared data sets throughout her career, which was important, very, very important in the history of the field. And again, that's going to come up. And she's also very well known for saying computing is too important to be left to men, which It was a nice slogan, and she's very much in the UK, very much associated with trying to get more women into computer science. But the starting point, as I said, the starting point for this talk is a very, very short paper that she wrote in 2007 as she was given 2 major awards at that point, and this paper was something that she wrote, as I say, just before she died. So let me just talk about the Cambridge history extremely briefly. This is something that I think is really interesting, but I haven't got time to go into it at all. Lydia Liu has been writing papers about this and the connection between Wittgenstein and Turing. But the connection that I want to mention is that Wittgenstein was in Cambridge as he had students who went to his seminars, and one of those students was a woman, extraordinary woman called Margaret Masterman. She attended his seminars and contributed to the Blue Book, which were the notes on his seminars, which he did, some of the notes on his seminars, which he did later draw on to write Philosophical Investigations, which is the later Wittgenstein book. Margaret Masterman is not nearly as well known as she should be, but she founded and led this Cambridge Language Research Unit starting in 1955. So this is really, really one of the very earliest units working on AI or computational linguistics. And effectively, she was Karen's PhD supervisor, although technically she wasn't, because she wasn't allowed to be, because she wasn't ever a formal faculty member. Anyway, so I want to draw your attention to that background, because now we've got this sort of historical link to Wittgenstein, which doesn't come into Karen's work very explicitly, but it is actually really rather important, I think, in what's going on, in the way she thinks about language and information. So specifically, I mean, obviously there's a huge amount to talk about in Karen's work, but I'm specifically interested in talking about what she said about the information layer. And it's really only a few paragraphs, but I was drawn to reread this and to think about it because I actually think that it has resonance for today. So I want to talk about what Karen actually said about the information layer in 2007, and then I'll move on to saying, why this is relevant now. So here's the main points. 2007, by the way, we're not really talking about neural models. They were known, but weren't being used all that much. Karen's thinking about language modeling, for instance, in terms of n-gram models. So, and information retrieval in terms of those sort of models too. So she sees NLIP as seamless, emphasizing very simple statistical techniques. N-gram models are really quite simple probabilistic models compared with the modern models we use. And what she's doing, though, is talking not about the models, but about the data. And I like this phrase, the vast language stuff that exists electronically. And she envisages this as accessible and directly used by computer systems, generally. Not just human users are going to access this, but generally computer systems are going to access this. And that is actually really quite striking, and I think quite important and really quite interesting. So focus on data, concentrate on computer systems. Now, she says something about in the layer part is because she's talking about the architecture of computer systems in terms of things like the operating system, the hardware layer. And I think she may have been thinking about the OSI model of computer networking. I'm not really going to talk about this. This isn't something that has sort of totally resonated with me. I'm going to talk about this possibility of the information layer being part of systems in more general terms, not as a specific layer in computer architecture. And she contrasted this idea with a semantic web, which I won't really talk about. If you know about it, then great. And if you don't, never mind. It was close to peak hype in 2007, but her argument was there wasn't really going to be any need to use formal languages for everything. Obviously, you need formal languages for some things, but no need to use it formal language generally. Natural language was going to play this role. Okay. Here's a slide which, please don't take it terribly seriously, but it's my best attempt to start talking about information and the vast language stuff that exists electronically. And this is what I see as the available text data for researchers on a log scale. And it starts off with the Brown corpus, which is around 1965-ish. And this, when the Brown corpus was introduced, it's 1 million words of data, American English, all dating from 1961. And there were hard disks around at the time, but the cost of storing the 1 million words of the Brown corpus on hard disk would have been around $25,000. That's not adjusted for inflation, so that would have bought you several houses. And so there's this situation that people had, this corpus of 1 million words and couldn't use it except with tape, which is a very difficult thing to do anything interesting with. And that situation stayed sort of not exactly constant, but it didn't change all that much until the late 1980s. And then you get this steep rise in the available data with things like the Trek corpora, the British National Corpus, and you also get a real rise in the availability of disk space. And those things happen at the same time, obviously not coincidental. And so you've got this inflection point, and I believe the inflection point is real. And then we've got a fairly constant increase in terms of, obviously exponential, because I'm doing this on a log scale. And yeah, we can talk about the details if you like. Now, don't take this terribly seriously. It's something I created for this talk, but it gives you some idea of what's been happening, I think. So I'm going to just very briefly say that there are, very introduction gave you some idea about this, but I've been working on a number of different areas over the years since the mid-1980s. And I started off working as a research assistant for Karen on natural language interfaces to databases of all things. And the DELPH-IN work essentially started in the early 1990s before DELPH-IN itself existed. So that's about formal, symbolic natural language processing. But I have, over the years, more or less always done statistical processing of various sorts, using corpora since I was able to use corpora. And the project we had on augmentative and alternative communication used some very, very simple statistical techniques. And I did work on the semantic web, despite the fact it was hyped. As I said, in the last few years, I've mostly been working with PhD students. I've done a lot more neural network work and lots of academic admin. So that's brought me into various broader research issues, including the way that natural language processing interacts with the rest of computer science. So I just wanted to give you that slide to give you some brief idea of the various points, which I'm not going to go into explicitly, where what I'm talking about intersects with research I've done. I hope, therefore, I've got some knowledge of a fairly broad range of topics, shallow knowledge of a fairly broad range of topics. So what I'm planning to do is to use Karen's idea as a jumping off point. I'm not trying to reconstruct specifically exactly what she might have intended, but I'm trying to use it as a different way into where we are this year, 2024, thinking about computer systems in general, use of natural language information, and considering the language data itself as the main object of interest, this vast quantity of stuff that's out there, not the models. So this underlying idea, as I said right at the beginning, is because I think it's absolutely essential that we get better abstractions and metaphors to support people who are thinking about what's happening, about the way that systems are changing and so on. I'm going to do something which is a bit dodgy, but it's very useful for me to be able to think about things in these very, very simplified terms sometimes. There's, as I see it, three overlapping areas of human knowledge and mental competence which are involved in what we're doing with NLIP systems. It's language itself. Obviously, we all speak different, many people speak different languages. And so, there's that area, the syntax, semantics, the lexicon of your particular language. There's common sense knowledge, which isn't at all easy to define, but by that I mean the sort of competence that you assume an adult human is going to share with you. Some of that's also shared by animals. I'm talking about things like if I pick up a pen and let go of it, it's going to drop. That's a sort of knowledge that's shared by animals in the sense that a dog will understand that something is going to drop if you let go of it, or going to go over there if you throw it. And this is absolutely crucial. You can't really have language understanding without having some common sense knowledge. And then there's book knowledge, this sort of general knowledge, things like quiz shows, and also the specialist knowledge of law, knowledge of medicine, and so on. And book knowledge isn't, of course, a standard term, but it's just the best one I could think of for today. So classic NLP, symbolic or statistical, is focused on one, but you cannot fully separate it from the common sense knowledge. Information retrieval focuses on three. And to the extent that you use language as your interface to the information retrieval system, then 1 and 2 can get involved too. But they classically have been separated. And so where we're going now is sort of really, really interesting, because modern LLMs, as far as I can see, are okay on 1 for languages with enough data, and pretty good on 3, at least superficially, but they're not as good on 1 and 3 as they on 2 as they are on 1 and 3. And here's a rabbit hole. This is my first rabbit hole. There's a focus on LLMs and exams, and that's a sort of interesting thing to do. Okay, so that's my gross simplification, that there's 3 areas of knowledge. And the crucial thing at the moment, I think, is how much common sense knowledge can we get out of the information layer with current models or with other models potentially. This is where symbolic NLP got stuck, and early statistical approaches got quite a long way with very simple techniques. And neural networks model sequences and generalize better. So even when you don't train them on vast quantities of data, things were already getting better. And now we're in this very, very interesting situation of trying to figure out how much is going on with modern LLMs. And there's all sorts of things which are going on which are quite weird in some ways. For instance, people are finding that including computer code in training seems to help with the language, common sense potentially abilities of LLMs. Training on multimodal data could help, not clear how much. And then we start going into the even more data and possibly artificial training data, which I'll come back to later. And I'm not really going, I mean, this is a total rabbit hole, but common sense is almost never fully explicit in language, but it's really important to language. And some aspects of common sense may not even be expressible in language. Anyway, as I say, that's a rabbit hole. I'm going to switch to actually doing something a little bit strange, which is just to talk about me attempting to use a modern LLM-based system on a genuine query. Now, you could say I'm cherry picking, except that this is literally the first time I tried using Microsoft Copilot, and it's a genuine query which is not in any sense using any specialist knowledge. I was reading a book about the history of the Stuarts in the family of monarchs of England and Scotland, yeah, and Wales too. And I was just sort of asking this question, but wasn't answered by the book I was reading. And so I sort of thought, okay, well, this is sort of an open-ended question. It's not one I'm going to find a good answer to necessarily by the normal sort of search. Why not actually try using these things, one of these things? So I asked Copilot, why did James II, Stuart King, convert to Catholicism? And it comes up with very nice syntax, very clear, and so on. The trouble is, the answers aren't actually really good if you know anything about the sort of history. So early life and upbringing, blah, blah, blah. Yeah, okay, that's sort of okay, but it's seriously waffly. Influence of his wife, Mary of Modena. Well, actually, he converted before that marriage, so it couldn't have been anything to do with her that he converted to Catholicism. It was actually the previous wife, and so there may have been something going on there, but we may have a confusion between wives going on here. Political and personal motivations, divine right of kings. Okay, that could be interesting. Bit peculiar though, because Anglicans at the time, James II would have been Anglican before he converted. This is perfectly in line with Anglicanism. And then this idea that religious tensions in England, James II's conversion can be seen as a response to these tensions. His conversion increased the tensions and led eventually to him being deposed in the so-called Glorious Revolution. So, okay, I wasn't terribly impressed by that. I went on, having a dialogue with the thing, and yeah, good that you can have a dialogue with a system. That's actually impressive in some sense. So I'm asking it for sources. And here's some sources that shed light on James's view of the divine right of kings, blah, 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 blah. His treatise written in 1599 for his son, Prince Henry. Now, there's a problem here because he wasn't actually alive at the time. This is James I rather than James II. Okay, so, as I say, I'm not technically cherry picking because this is my first attempt to actually use the thing, and maybe it's not very good on history, maybe it's not very good on dates, or maybe it was just I was just unlucky, or it was just unlucky. I could go into more detail. The cited sources that he was giving me were very general. Some were not trustworthy. They looked like they were auto-generated. It doesn't find the authoritative sources, which I eventually went looking for in Google Books. Maybe that's not possible for Copilot. It's unclear what the user model is. What is it assuming about the user who's asking these questions? But the thing that sort of really bothered me here was this discrepancy between the pre-training from which it's drawing its answers, I believe, and what the user sees. This is something that is going to be really, really important, I think, in how one might actually use LLMs. If you don't actually have any access to the sources it's using, and you might never get that if we have fair use copyright claim only applying to training. Anyway, this is, as I said, something that I feel was important for me in not just sort of, don't want to say LLMs are rubbish. I don't want to be sort of, grumpy old person saying, it's just hype. It's not just hype, but some fairly interesting things are going on here. And this is actually important for what I'm going to talk about next, which is systems and the use of the information layer. Because if it's sort of so lacking in common sense knowledge that it can't tell that somebody couldn't write something before they were born, then that actually may mean that there's some sort of fairly fundamental limitations in using these things without a human user who can say that's rubbish. Okay. And as I say, I'm aware that I might be, this might be unfair to the system in some sense, But there's plenty of things out there which are now showing that there's a serious lack of some sorts of common sense knowledge in LLMs. And this, I really think this matters. And as I started off by saying, I really think that how we conceptualize these things is incredibly important in what we think of as possible uses. Okay, so I want to switch back to Karen's idea of the information layer as something that's generally accessible by systems. But what I'm trying to emphasize here is I'm not just talking about modern LLMs as the way you're going to do this, because it seems that there are some issues there. Okay. Natural language processing, natural language and information processing applications predominantly assume a direct interface to a human user. So the type of things that you're talking about, machine translation, which is really very good now. You have a choice whether to use a machine translation system, and you have a choice about whether to use the particular output, and you often have a choice about whether to use the system at all. Not everybody does have that choice, but a lot of people do. The two sort of main exceptions to this are information extraction and text categorization, but even those are usually part of a human-oriented system. So what Karen is arguing back in 2007 is that natural language capabilities could be a general and integral part of computer systems. And that's still radical, even in this context where everybody's saying how wonderful LLMs are and how, great. Yeah. So she's arguing that they could be a general and integral part of computer systems. Now, I want to use systems, as I said right at the beginning. I'm not particularly sure exactly what Karen meant by the layer architecture and the role in the layer architecture. Maybe somebody else can work that out. But what I want to do is to talk about systems, the systems perspective in a broad engineering sense. A system is an organized whole, including software and hardware and sensors, but also the people. And I'm going to use as an illustrative example, Transport for London's Network Management Controls Centre. And I must admit, I know more or less nothing about this, apart from what I've read in a couple of short-ish articles, which I've given citations for at the end. There are, of course, systems that I know much more about, including various academic administrative systems, but I thought that would involve far too much self-censorship if I start speaking about those. So here we are with, I'm talking about this as what I think is a reasonably good example. But as I said at the beginning, this comes to some extent from thinking about this danger that we see machine learning and natural language processing now, and AI in general, as being separate from other aspects of computer science. I really think those things need to be thought of as together in some way. So Transport for London Network Management. That picture shows you the South Circular Road, which is a major London route. And there's a traffic jam, or at least slow traffic there. And that's how it often is. Average speed of traffic in London is something like 9 miles an hour during much of the day. Transport for London keeps this going. So they're responsible for traffic movement, they're responsible for tunnels, they're responsible for London buses. They're actually also responsible for the underground, but the particular system I'm talking about is just the, this part. There's another system for the underground. They have lots and lots and lots of data, road sensors, CCTV, reports from bus drivers, and then all sorts of other things like the weather and stuff like that comes into it. Have to interact with the other Transport for London operations, with the emergency services and so on. They have plans for major incidents. Operation London Bridge was for the death of Queen Elizabeth II and all the preparation that had to go into that. Operation Menai Bridge is for the death of King Charles III. So they have to have plans for all the things that are going to happen then, and those have to be prepared in advance and thought out very quickly, carefully, but not quickly. And according to these articles, or this particular article that I cite here, a major win for automation will be detection of incidents automatically. Currently, what's going on is that human operators are scanning all these inputs, and they can't keep on adding operators. Now, the article actually says they can't keep on adding operators because it would be too expensive and there wouldn't be enough physical space for them. But it occurs to me that a major reason you can't keep on adding human operators is because this isn't a modular system. You can't keep on adding human operators because it would mean they all had to talk to each other, and that's clearly not possible. So could the information layer, again, coming back to this concentration on the vast natural language stuff that's out there, could that actually be useful? This is clearly something that they've thought about, and they've got, they've had some ideas about this, but could they actually use the information layer in their systems to improve their systems? This is clearly something that's going to be really important if traffic is going to keep running in London. You could run speech recognition systems for the bus drivers, who are then a major source of information for the control center. And doing that would allow multiple people to quickly see what particular bus drivers were saying, and it would allow the data to be stored and potentially searched and so on, which could be useful not just for the immediate incident, but for future planning. You could combine text generated from the bus driver's speech with information extraction, and you could support that with the sensor data and so on. So getting specific pieces of information about incidents from what the bus drivers are saying without necessarily having to go through a human to extract that information. That seems to me, pretty well within the range of modern technology. Actually, been the range of modern technology for quite a long time, if the speech recognition works well enough, which it should now. Multimodal presentation of the incidents to operators, so not just giving them the pictures and giving them the data from the traffic monitors and so on, but actually saying something briefly in natural language to explain to the operator, what the system thinks is going on. That again seems something that's interesting, an interesting option and plausible. And then there's a sort of suggestion in one of these articles that they might want to use social media. That seems to me much more complicated, and yeah, maybe. More speculatively, longer term, yes, you might want to start having these systems behave more or less autonomously. For instance, altering the timing of traffic lights, which is something that I believe is done manually in response to incidents, so that more things go through. Communicating with other systems, I think this is a really interesting option, and I'm going to come back to that. Prediction of possible incidents, things like queues for gasoline. This causes major traffic jams under some circumstances, and support for planning and so on. So, there's lots of ideas that one could imagine could be useful, but how would you actually do it? How would you actually design a system incorporating an information layer in the way that Karen was envisaging? I mean, there's really, really very little guidance out there as to how you might incorporate modern language technology into computer systems. This is not something I'm putting on a slide, but I'm not at all sure that the people who are developing the modern language technology even realize how much of an issue this is. And, I have, from conversations that I've had, it would be unfair of me to say conversations with whom, but even the potential of the moderately sized pre-trained LLMs has not been properly investigated yet. It's not the case that, if you go to a computer science degree that you're going to find out how you can take advantage of language technology. So there's some things that are coming out which are potentially really, really helpful. There's this paper by people in my department about data-oriented architecture, which is talking about machine learning systems, a very strong emphasis on flexibility. But there's almost nothing about language or systems accessing this sort of general information layer. There's a design principle for all machine learning systems to emphasize initial data collection and to build in meaningful evaluation right from the start. But actually thinking about that with respect to building in information layer, this is something that, you know, people aren't being trained to do very well yet. And that's a huge amount of work that would have to go into working out how to do this, working out methodologies. So designing in natural language is really attractive, I think, for flexibility and future development. But Karen's emphasis on starting simple still seems appropriate, even though we have these much more advanced systems. Because starting with the simple systems, starting with the more simple techniques and with much less data avoids some of the pitfalls that we will run into if we start using things trained on trillions of words and try and make them work in a system of this type. And I'm just going to plug Aurélie Eberlo's work here. Aurélie is somebody I've worked with for years and was very helpful in giving me ideas about, you know, how to talk about the current technology. As I said, having me having been somewhat out of the field for some time. But Aurélie herself is working with much smaller data than, deliberately working with much smaller data than with the modern GPT-4s and so on of this world. Okay, so what I really want to say here is that I think that Karen's idea was very interesting and potentially very important, but I think that there's just this huge gap in knowing how to actually do it right now. There's something else that Karen, I actually originally thought that she'd said this explicitly, but reading the paper again, it isn't said explicitly, but it sort of, I think, is a very direct inference from what she said. If you have systems which are all making use of natural language as an integral part of the system, and they can both analyze natural language and generate natural language, which seems perfectly reasonable, then they could communicate with each other via natural language. Especially that's relevant for ad hoc communication, not planned interaction between systems. And as I say, I don't know whether Karen really intended this, but it seems to me a clear consequence and a really interesting consequence. And I think she may have intended it, given her slightly rude remarks about the semantic web, where that's also clearly a motivation. So Transport for London is a possible example. You want to interact with multiple other systems, they're unpredictable situations, may or may not have human operators available. And so it's very interesting, this idea that you can interact with another system via natural language, and maybe there's a human there, or maybe there isn't a human there, but you know, you might get something even if there isn't a human. I think that's got a huge amount of potential. And again, yes, it's implausible to develop formal interfaces for everything. And even if you do, even with the semantic web technology, it turned out that even though they sort of agreed on the syntax, it turned out in many cases using semantic web for scientific knowledge, there was a sort of lack of full understanding of the actual semantics of the information. So this seems to me a very interesting line of thought. That said, if you have computer-to-computer natural language dialogue, it might be human interpretable, but it might not be. There's no guarantees. And this is where I won't try and explain this in detail, but these sort of ideas of signaling games where you try and see whether systems can learn to communicate with each other. When you do this sort of from scratch, the symbols that the systems learn are not necessarily language-like. So you could end up with two systems communicating with each other, possibly with things that sort of look a bit language-like, but aren't actually human interpretable. So yeah, that should have had a rabbit hole marker. Oops. Okay. So I want to talk now, just want to finish off by talking about prospects for the information layer. So viewing the information layer as all the language stuff out there, or really what I'm talking about is all the text out there. Where are we going? By the way, I'm sort of talking about English, but I'm not really specifically talking about English because to quite a large extent, from the perspective of trying to derive, for instance, common sense information, I'm not sure that it matters that much if the information is, which language the information is in. It matters clearly a huge amount for minority languages, less studied languages, but I am predominantly talking about English. So here's a projection, my projection of what's going to happen with the available text data. So taking the slide I had earlier and projecting it for another 15 years or so. And I think it's going to level off. I think it has to level off. I mean, how much language data could be available? Here's a very back of the envelope calculation. If you've got 10% of the world population, say, generating 3,000 words of text per day each, which is a lot, that's 10 to the 15 words of real data a year. And that's a big number, but the latest LLMs are being trained on around 10 to the 14 tokens. This is basically data from the Common Crawl, which is the web data. And the latest versions of this, the latest release data set, sorry, this Red Pajama data set, I think is 30 trillion tokens. And the latest large language models are being trained on more data than that, some that data not being publicly available. So I think that, this amount of language data is clearly going to be flattening off soon. And of course, the Googles and Microsofts and so on of this world can start accessing data that's not publicly available, but there's a limit to that too. How much language data should LLMs actually need? Guy Emerson, my colleague, has got an order of magnitude estimation that the GPT-4 trained data is about 1 million years exposure for a single human. Humans do not need more than about 10 years to learn their language perfectly and to learn lots of other things as well. And even with language models, even with machine learning models, you can learn syntax of a particular language with much less data. Sorry, you may have heard the siren going outside. I hope it didn't disturb you too much. And how much data do you need to learn common sense? Well, the answer is we don't know. So here is a slide which you really shouldn't take too seriously, but it's my version of what the main limitation has been for the technology, for the development of the utility, the use, of the information layer over the years. And clearly, to start off with, it was the technology, it was the disk cost. I think probably from around 1990 to 2000, there was a limitation of the amount of data. As the web developed, we got more and more data, but our models were a bit boring. In recent years, the models have got much better, but it wasn't until very recently that the speed of the models got better. So that's a lot of what's been going on in the last few years, is that proper computer science has happened with large language models, and now they're much faster than they were. They could be much faster still. I think, at least my colleagues think that, but who knows? I think that we're getting to a phase where the data, there just won't be that much more data. There won't be many more orders of magnitude to go. The tech in terms of the, processing is probably not going to be the limiting factor. I think the models are going to be the limiting factor. So say this is super subjective. You can take it seriously or not as you like, but that's where I think things are going. We need better models. And how can we tell what's in the information layer? This is one of my last slides, I think. There's lots of investigations of the common crawl database and so on. And they're very, very useful, but they're at the meta level. They're saying, which websites, are being crawled, how much duplication there is, and so on. Sturgeon's law applies. The polite version of this is 90% of everything is crud. I think that's sort of squared for the web. Duplication, massive issue. And of course, fake sites, fake news, pages generated by language models. So how much data there really is out there in the information there, we don't know. And how do you get at the good stuff? This notion of what the good stuff is very unclear. We need specialist tools to investigate the content. You can't just look at this thing, just too big. And the tools, language models could be part of the tools, could be part of the technology, but it can't be the current generation of large language models as far as I can see. They're not standardized, they don't have meaningful evaluation, and they don't have reproducible results. And that, I think, is a minimal requirement for a sort of scientific investigation of what's in the information there. The alternative for now, when you're actually building models, is to only use selected data sources, such as Wikipedia, which is not at all perfect, but at least you've got some idea of what's in it, plus artificial data. I have some slides on artificial data, but what I'm really just going to say is that I think it's actually really important for investigating these sort of holes in the technology. I'm not saying in any sense that this sort of augments the information layer, as Karen meant it, but I think that thinking about artificial data is going to be quite important. And I've got some citations here, but also the idea of augmenting natural data. It turns out that visual genome is a very, very interesting corpus, for instance. In the interest of time, I will skip a few slides which are about some experiments we did a few years ago on artificially generating training and data and evaluating on this artificial data. I found this very, very interesting and very helpful in understanding, but I think I don't really have time to go through it properly. So, okay. There's also something which I am aware that I don't know nearly enough about, but the rights to the information layer. And this is clearly going to be very important over the next couple of years, working out what's exactly going to happen with copyright law and so on. And clearly there's a lot of people trying to resist the sale of their data, for instance. There's quite a lot of work on data trusts and similar initiatives about what do you do with, say, patient data? How can you make use of that in a fair and reasonable way? But they've hardly talked about language data at all. And I hope that there's people listening to this who are much better qualified to talk about this than I am. Right, so I reckon that's about it. I think that Karen's information layer concept, so sort of thinking back now on where this led me, I think that Karen's information layer concept was very, very helpful in making sure, keep focused on the data, not on the current models. I don't think it's layer in the architecture sense, but this idea of natural language becoming general in systems, I think is I think is where we're going to be going, and I think it's very important, that idea. And there's many open questions, some of which I just alluded to with the rights part, but there's other open questions which are, I think, less well studied. This idea of natural language communication operating between systems, I think that's where it's going. Yeah, I think that's a very interesting but also very open idea. How do we differentiate the language stuff? I mean, this comes into sort of talking about fake news and so on, but it's not quite what I mean by this. I think there's a whole load of things to talk about in terms of, I don't know, some types of metadata that could be usefully used here. And large language models have huge potential, especially, I think, for democratizing coding and data processing. But I do think there's an issue about whether large language model use in systems, in computer systems, is being investigated and developed right now. Okay, here's some acknowledgements for a whole load of people, none of whom are in any sense responsible for this talk, but I have been talking to a lot of people over the last year or so about various aspects of this. And I have got some citations at the end of the slides. So if we're sharing the slides, then you can see those. So that's it. I will finish there.
Thank you. Thank you so much, Ann, for that very, very engaging presentation. And we are now happy to move into our discussion and Q&A period. And just a reminder to everyone, if you have a question, then the preferred method is for you to raise your hand. And then when we call upon you, you can unmute and turn on your video so that the speaker can see you, and then you can ask the question yourself. But if you're in a place where you are not able to unmute or turn on your video, then please write your question on chat, and then I'll be happy to convey the question to the speaker on your behalf. All right, so there's already a hand raised. Uchenna, would you like to go ahead and ask your question?
Hi. Hello, Anne. Thanks for your presentation. I enjoyed that. It was interesting hearing about the different layers that you mentioned regarding the way it's seen by the AI systems. First of all, you talked about the use of these layers, being able to assess them and things like that. I wanted to ask as a computer scientist, are there challenges regarding the ownership of such data, the ownership of the large language models, the different model recognition systems? Maybe this person says, hey, it's my language, or this person says, hey, or this country says it's ours, another country says it's ours, and the computer needs to access all that. Do you think there are any challenges regarding that would disturb the system? The second question is regarding accessing such sources, because you said accessing such sources is important and that fair use shouldn't, in copyright, it's currently limited to the purposes of training.
Okay, I probably need to explain that a bit better.
Okay.
So I can start with your first question. I mean, basically to say there's a huge amount going on here. And I know that there's a huge amount going on here. And there are many people, even in Cambridge, who are working on these sort of things. I really don't think I should be talking about it very much because I know I'm so ignorant of what the situation is. I mean, there are lawsuits that are going on right now concerning, for instance, the use of the New York Times data in the training of the GPT models. And the point I wanted to make is that people have been using this data because it's been accessible via the web. And to an extent, I think that that was fair enough when you had language models which just used like sequences of 5 words. That seems to me to fall under a reasonable definition of fair use. But what's going on now, and has been very clearly demonstrated, is that the language models are memorizing an awful lot more than that. Now, what seems to be happening, and I mean, I don't know what the limit is. I don't think there's any formal limit in the length of text that they're memorizing. So then there becomes the question of, okay, could that be fair use? Now, what seems to be going on is that though they memorize that data, they don't in some sense record the source. It's not literally being memorized in the sense of, this whole sequence is there. It's being memorized in the sense that these transitions are being memorized. So it isn't necessarily going to be able to reconstruct it word for word. And they don't have any record of the source, I think, in the current models. And anyway, even if they did, if you have copyright data that's used in training, but a human is using the system for search or information retrieval, they're not showing that data to the human because they can't under the interpretation of fair use. So we've got this inevitable discrepancy with the systems having been trained on data, which they are and asserting things to the user on the basis of that data, but they then cannot apparently show the user what that data is. And that's both for technical reasons, that they haven't really recorded the source and haven't really recorded the data properly, and also, I think, probably this legal reason. So I think that's where we are at the moment. I could be a bit wrong about some of that, by the way, because it's all very, very muddy. The lawsuits are in progress, and what's going to happen, none of us know.
So it's definitely a challenge that we need to resolve regarding policy.
And it's going to, and the situation is going to end up different in every single country, because copyright law is, well, not every single country, but many countries, because copyright law is different in the US from the rest of the world. And I mean, it's basically a horrendous mess as far as I can see. But as I say, I'm really not very qualified to talk about this. So that's what I was alluding to.
I just asked because intellectual property is my own area of specialization. I've done some research with your colleagues at Cambridge at the Faculty of Law, Dr. Henning and others, and wanted to hear from a computer person exactly where we would be heading and how we could rearrange our policy analysis to better support such systems.
Yes, and I mean, part of what I'm trying to do is not to directly talk about any of these things, because as I say, I know nothing about them, although I am sort of, aware of what's going on to some extent. But I think that if you're going to conceptualize things like fair use, you have to have the reasonable concept of what the models are doing. And that's where I think I maybe have a niche in trying to help people understand what the data is, and understand, what the models are.
If you have anything written regarding that, I'll be very glad to have access to it.
Yeah, nothing yet, but yes, definitely working on that.
Thank you.
Thank you, Jenna. I have a question. You mentioned during your talk this very interesting thing that common sense may not even be expressible in natural language, and that could be kind of one of the downsides of relying heavily on natural language. And I'm kind of wondering what's your take on the reason for this. Is it that we don't have the right words in the languages that we have today to express certain concepts, or is there something about the structure of the language itself that makes it difficult or impossible to express certain common sense knowledge or concepts? And kind of people are also talking about this from the necessity of multimodal agents, right? So if I mean, one part of this is that there's just a lot more data available in the form of images and sound than we have jotted down in language. And so if we don't go to multimodal, we are missing out on a lot of data. But there's also possibly something to be said about maybe images and sound being able to capture certain data that just is very, very difficult, if not impossible, to express in natural language. So what are your thoughts on this?
So I think, I think images should help, although it's sort of interesting that they don't seem to be helping as much as you might have expected. But I think if you're talking, you know, I didn't talk about this. I sort of alluded to it a bit, but my own personal view is that things have to be grounded, and that grounding is much more than just saying, you know, you've got images here. It's this whole sort of, you know, the whole physical world. So that's why I like the push example. I should know more about this, but it's George Lakoff's group in Berkeley was working on this decades ago. And if you sort of think about if they were trying to work out exactly what the meaning of push was, you know, Lakoff told me, I could have got this wrong, but Lakoff, I think, told me in the 1990s that they decided there were 90 different meanings for push, and all to do with exactly, you know, what physical operation was being involved. I'm not even sure whether the metaphorical ones were, you know, part of that 90. Now, if you tried to write down 90 different meanings of push in natural language, you wouldn't, you know, you have to be talking about this in terms of the actual physical, tactile stuff that's going on. But I think if you want to talk about those distinctions, you could do it in natural language, but not in natural language, if you see what I mean. So my personal version of things is that there's not stuff which is completely inexpressible in natural language. It's just that when we develop particular areas of science and so on, we develop our own sort of additions to natural language to help us to express that. Although there's some things where even that isn't clear that works. I mean, talking about tastes and scents and smells and so on in natural languages, not particularly productive, really. I mean, that's a whole interesting setup where there's different languages. Some languages have much more capability in that direction than others. But I think that, my personal sort of philosophical viewpoint, to the extent you can say I've got a philosophical viewpoint, is that natural language is about aligning humans. Humans have lots and lots and lots of shared background, because we're humans and because we're physical entities moving in the world and sensing the world and so on, and that language is about aligning those perceptions, not about transmitting information. And that if you take that perspective, then there's so much of this stuff that's intangible.
You see, I have a follow-up, but I'll let Avery ask her question first. Avery, would you like to go ahead?
Go ahead and do the follow-up, and I'll come after that.
Oh, all right. Okay. Yeah. So I was just so just kind of more on this limitations of natural languages. So you mentioned the benefits of computer systems talking to each other in natural language. Kind of perhaps maybe the whole interface should be that, and you mentioned the benefit of interpretability. Although there is some recent research that's kind of been demonstrating that when you get LLMs to talk to each other and you kind of give them an explicit objective that's slightly different from the objective of the human who is able to read the responses between these LLMs, then the LLMs kind of learn over time to collude. Basically they use stenographic methods to pass messages to each other, which to the human observer looks innocuous, but they are really coordinating on some strategy underneath to optimize their goals further. So I'm kind of wondering, this is I don't even know whether this is really a limitation of natural language and the ambiguity that it has, or whether this is just an underlying underlying difficulty that is always going to remain there.
I just don't know, to be honest. I mean, I had that one slide which sort of alludes to some work we did quite a few years ago, and I must admit, I haven't followed up on the recent research there. although I sort of know what you were talking about there. I mean, we found that systems, when you ask them to, say whether they say something, sorry, I hate using this anthropomorphic language. Systems sort of do things like focus on the, 7th pixel from the top left or something like that, and use that to just, all sorts of things that humans can't do. So that's basically why I have that. I mean, I think it's something to investigate. I don't think it's impossible that we could actually do this in a way that it retained interpretability, but it's not straightforward. I think that's as far as I'm going to go there.
Yeah, I see. I mean, yeah. So, I mean, if we broaden the interface even further, there might be even more stronger and more powerful stenographic methods that they can use, right? At least with natural language, there is a little bit of limitation that they have. So that's an
yes, but I mean,
it
depends on the objectives, doesn't it? Because with if you're setting it up so the objective is a bit less artificial than the ones we use in the Lewis games and things, then maybe you don't get this behavior. I mean, I don't know, but I think that would be the way to to start doing it. I mean. Yeah.
Very nice. Thank you. Avery, please go ahead and ask your question.
Sorry. Okay, now I'm unmuted. Hi, thanks so much for this really interesting talk. Very much appreciate bringing in Margaret Masterman, who I very much am a fan of. I want to ask you about Wittgenstein, because we're talking about grounding. And, as you know, and for people on the call who aren't readers of Wittgenstein says meaning only emerges in use, sort of the ordinary game of language. However we're interacting with each other using language, that's how meaning happens. And what I've been thinking about is what is going to be the cost of kind of use with artificial agents at scale. And when you were bringing up these examples from talking with I don't remember which LLM, but maybe ChatGPT or something, and getting the dates wrong, but kind of right. It reminded me of this. I don't know if it's a scandal because no one was all that surprised, but we had this case in Canada where Air Canada's chatbot told, I don't know if you have come across this. So Air Canada had an AI chatbot that told a user who was trying to buy tickets in a situation of duress. This particular customer had gone through a bereavement, and there's a bereavement discount. And the chatbot gave the customer the wrong information about how to get the bereavement discount. Then Air Canada said, no, you have to pay this much larger amount. The user said, no, here's what your chatbot said. And Air Canada said, oh, well, our chatbot is solely responsible for its misinformation. We aren't. Now, the Canadian courts ruled that was not going to work, not going to fly, as it were. But it kind of brought up the costliness of these agents learning how to use language with human interacting other agents. And the cost of kind of learning how to give the right advice might just be so high that the business case for LLMs kind of falls apart. And I was thinking about the line that you had where you have models are costly, data is costly. What's going to happen in that the cost of use, which has different costs, different social costs? I don't know if you've been thinking about that, just something you want to speculate on there.
Yeah, I mean, you're touching on a lot of things which I think are really, really important. So, I mean, part of what I'm trying to do at the moment, as I said, is I haven't really started doing this, but to help people actually conceptualize or have good metaphors for LLMs, because it's just impossible to say, Air Canada wasn't responsible for that. It's just absurd. And I mean, I, personally even don't like using it to talk about the LLM. I don't think there's an individual in any sense there, but we're running into sort of limitations with language now. If I don't use it, what do I use? So I do use it, but so it's a computer system. But as soon as you start talking to a computer system in relatively fluent natural language, how on earth do you conceptualize it as anything other than a human? And this has been this problem that's come up time and time and time again. Now, I think you probably can persuade humans to interact with systems in natural language and not think of them as human. I mean, I think that people have sort of understood, what Alexa is in some sense, because of its limitations. And I think that stage has to happen with these models too. But I mean, I find Alexa and so on, in some sense, super worrying. I mean, I think there's a whole set of questions about what happened. I mean, that was actually, we have this project called Giving Voice to Digital Democracies, and there's been some some discussion there about, we've had a series of workshops where we brought together people from research and industry on some of these things. But I mean, Alexa is basically, okay, I don't want to say this too strongly, but if you conceptualize Alexa as a human, which you could do because you're talking to it in natural language, then what is that human? It's got to be a slave. And then you've got this situation where you have small children talking to something that has to be conceptualized in this way, as far as I see. Now, I'm not at all interested in the idea that this is harming Alexa, because there ain't anything there to harm. But I am interested in the idea that it might be harming the small children. And, so there's a whole set of things that have been going on already for a decade or so, which I find, potentially is sort of super worrying. And the ChatGPT sort of discussions and so on are just adding to that. And there's a vast set of things which I am really not going to be qualified to talk about exactly why this is happening, exactly the processes that are leading to this sort of situation. And I mean, from my very selfish perspective as somebody who wants to do, research in computational linguistics, it's actually, there's a lot of things going on which which complicate our ability to do research anymore, even never mind all the wider issues. So yeah. Sorry, that's a rather baggy answer, but I mean, a whole load of this stuff gets super baggy super quickly. Yeah.
No, thank you. That was very interesting. Thank you.
Thanks, Avery and Ann. Any final questions from the audience? Okay, so there's one audience member has communicated a question to me. I think it's came via direct message. So Atrisha asks, I'm very keen to know your thoughts on this question. How much do you think the capabilities of the models are determined by the nature of English language? Should we expect that we'll get the same capabilities, however measured, if we have same internet scale data on another language that's different in origin than English?
I don't see any strong reason for there being much difference in the sort of language, the type of languages where we've got a fairly large amount of data. There haven't been sort of massive structural differences that have been shown because of the nature of the language. There are lots of individual differences which are very interesting from a computational linguistics perspective. But even a language like Chinese, which is very different from English, of course, but where there's loads of data, I'm not aware of anything that's sort of suggesting that the types of results are massively different. I might be missing something, I'd say. And of course, when you go to languages which have very small amounts of data, then you just can't play these games. I mean, the current sort of generation of language models are using far more data than some of the earlier generations did on the whole. So there's some cases where you can actually do some modeling with quite relatively small amounts of data and get some interesting results. But you don't tend to use the current generation of language models. But on the whole, I think, I mean, there's a whole load of questions. Both English and Chinese have, basically speaking, got no morphology, or no reflectional morphology. I mean, they're very much very much weird compared to other human languages in that respect. But I don't think that that's had a massive effect on what goes on with but I don't know for sure.
Sounds good. Hi, Anne, would you like to go ahead and ask your question?
Yeah, so it's actually a follow-up from Atrisha's question. We had a speaker in the series, I think late last year, who was, I believe she was in the Netherlands, and she seemed to suggest that if German had been the lingua franca rather than English, then we would actually see something very different, because German is so much more precise. And because the English vocabulary, because English as a language actually has quite a few ambiguities that somehow made a difference in the LLM. But I would love to hear whether you have any thoughts on this, since it's well outside my area of expertise.
Well, I'm not trained as a linguist at all, but my initial reaction is that to say one language is more precise than another, there are artificial languages where you can be arbitrarily precise, and I think it's sort of basically the case that there may be more precision in the way people use German, perhaps, but I don't think there's and that could be interesting, but I don't think there's anything to say that German per se is more precise. German has huge amounts of ambiguity, just as English does. I mean, if you try and talk about syntactic ambiguity and you parse an English sentence of moderate length, you get tens of thousands of possible readings, and you do for German too. And I'm not aware of anything that suggests that it would make a lot of difference. There's some quite interesting things that go on in German which could make a difference for some of these effects of bias, for instance, because German marks grammatical gender in a way that sort of goes with natural gender, although not perfectly. So there's some things where it would make a difference if you went to a language like that. But I don't see a massive difference. But I could be wrong. I just haven't seen any data that suggests it.
Perfect. Thank you. Any final questions? All right, then. Thank you very much, Anne, for that very, very engaging and thought-provoking presentation. And thank you to everyone in the audience for joining us today. And please also join us next week for the last seminar of this semester on Wednesday, April the 3rd, as we welcome Luciano Floridi, founding director of the Digital Ethics Center and a professor in the Cognitive Science program at Yale University, for a talk on what is the impact of AI on democracy. We look forward to seeing you all then.